Here we go. Still chapter 7, but not for very long. Yeah, that's good enough. We are now at the last section of chapter 7. Equations that have the inverse trig in it. And so it's a very short lesson. It sometimes can be complicated only because we just don't like to handle inverse trig stuff. I mean, you remember the lesson we already had, graphing them and changing the domain and the range and from the original trig function, how it switches. But it's still needed because it comes up all the time. Bye, guys. And so after you get your My Math Lab homework done for this, then that would tell you, hey, we'll be done with the chapter and you'll be taking a test. Most likely Thursday will be your test. I think I already put up a practice test in Naiku. So go to a.naiku.net and I sent you your information on how to log in now. Okay? I don't think you'll need a code. If it needs a code, I'll have to give your class the code. All right. First problem. We're going to solve y equals 3 cosine of 2x. And that means we're solving it for x is what it always means. Solving it for x. That's what it always means when we're solving. We're all finding out what x has to be. So kind of interesting that we're saying it. If I said solve this, y equals 3x minus 5 for x, and we're just solving it for x. We just do the opposite both sides. But in this case, the opposite. Now, be careful. This 2x is an argument. It's an angle. And I don't know what x is, so I can't just plug it in. I need to isolate and get everything away. So just like you would do on this problem, how you would divide both sides by 3, well, I divide both sides by 3 here as well. So y over 3 equals to the cosine of 2x. Now, this is very similar to if I had y over 3 equals the square root of 3x minus 2. How would I get rid of the square root? I'd have to do the opposite of square root. That would have been squaring it. When I say opposite, it's the inverse operation. Well, the inverse operation of cosine is inverse cosine or arc cosine. Arc cosine, both sides. And when you arc cosine both sides, you now have the arc cosine or the inverse cosine of y over 3 is now equal to 2x because the inverse cosine and cosine are inverse. They cancel out, leaving 2x. So I'm one step away for solving this for x. X is the inverse of cosine of y over 3 all divided by 2. Okay. And I don't know what he put here. That was the original function. There's probably a reason that he is only showing you the black. Pi over 2 to pi over 2. Well, he stopped at pi. We'll see what he said in his solution. First of all, I want to pay attention. Do we have the same answer? We have the same answer. Okay, because y equals 3 cosine of 2x. Okay, it's a double angle. Cosine usually goes from 0 to pi. That's your principal angles of cosine. Let's check out another one. Solve 2 arc sine of x equals to pi. Again, that must mean we're solving for x. So we're either going to get a value or we're going to get a function. Not necessarily, yes, well, another equation. Get rid of that 2 by dividing both sides by 2. That leaves me the arc sine of x equals pi over 2. The opposite of arc sine would be to sine both sides. Oh. That cancels out sine and arc sine cancel out, leaving x equals to the sine of pi over 2, which everybody in this class knows that sine of this angle, 90 degrees or pi over 2, is a 1. X has to be 1. That was way too simple. I really need to make you do that more often to check your answers when you solve an equation to see if it works. Because a lot of times it looks like it will work, but it's an extraneous answer. 2 arc sine of 1, is it equal to pi, is the question. Well, this question here says, the sine of what equals to 1? The sine of a 90-degree angle, that's 2 pi over 2 must be equal to pi. 2's cancel. It works out. X is 1. I like this, that he's doing this checking. You know. All right, number 3. Oh, I never did like these. I have 2 different arc functions, 2 different inverse going on at the same time. Here's my advice. He probably does a lot of work with substituting for u's and whatnot. Let's just solve this side. Because this is a variable, I can't solve it. This says it's an arc sine is a half. What angle? What angle? In other words, if I write this by itself, arc sine of a 1/2 equals some angle. Let me call it x of 2 to make sure I don't mix it up with this x right here. And if I want to solve this, I would sine both sides like I did in the last problem. Sine. Because what I'm asking is, the sine of what gives you a half? So if I sine both sides, that cancels, leaving 1/2 equals to the sine of this x sub 2. The sine of what is a half? Well, I remember that now. In my first quadrant, that would be a 30-degree angle. And he's using x's, so he's talking about radians. But I'm going to write it because my brain thinks 30. And so this is the angle that I'm calling x sub 2. Right here, that's the angle. The sine of that angle, x sub 2. 1, 2, square root of 3. So that angle is a 30-degree angle, or pi over 6. So what I'm going to write down here is the arc cosine of x equals to pi over 6. Cosine both sides. That gets rid of the arc cosine. Cosine both sides. Well, what's the cosine of pi over 6? Same triangle. This is still the same angle. Cosine is adjacent over hypotenuse. So I'm going to call the answer that x has to be square root of 3 over 2. Let me run and see what he wrote. X is square root of 3 over 2. There's the same triangle that I had. Now, there's his solution. He gets 1 page of work, 2 pages, and so, I don't know. Number 4. Now, this is not going to be fun at all. I can't even guarantee I can solve this one. Let me isolate, move this trig function, arc function over on this side. So that will give me the arc sine of x equals to a pi over 6 plus an arc cosine of x. The only thing I can see on the left is maybe to sine it. If I sine this side, I'd have to sine this side. At least the sine of arc sine will give me this x. And this is the sine of pi over 6 plus arc cosine of x. So this looks so crazy, but I'm going to say this is the sine of an a plus b. So I'll break it apart. X is sine of a, which is sine of pi over 6, times cosine, times cosine of arc cosine of x, plus cosine of pi over 6 times the sine of arc cosine of x. So x is, that's a sine of pi over 6 is a half. And then I still have the cosine of the arc cosine. That's times x because these two cancel out. Plus cosine of pi over 6 was square root of 3 over 2. And now I'm still stuck with sine of the arc cosine of x. Now, in reality, arc cosine of x is an angle. If I could find it, then I could do the sine of it. But what I'm going to do here, this is something we do in calculus. I haven't got to it yet because, well, they did it in Khan's Academy. If that's a right triangle and the cosine of something is x, so I'll call it a y. And I'll say y equals to the cosine, arc cosine of x. So arc cosine of this is the answer is an angle. So I called it y. Is x. So cosine is adjacent over hypotenuse. If I complete this triangle using Pythagorean theorem, I get 1 squared plus x squared is this missing side over here. I'll call a squared. If I take the square root of all that, I get a. So this side is 1 squared minus x squared. Now I can use this to my advantage because I already know x is x over 2. Oh, okay, see that? Plus the square root of 3 over 2 times whatever the sine of this angle is. Well, the sine of this angle is the square root of 1 minus x squared over 1. Opposite over hypotenuse. Oh, that makes it look nicer. So I can take this x minus 2 and take it over here. 1x minus half of x is an x over 2 is equal to the square root of 3 over 2 times 1 minus x squared square rooted. Now, I'm still not done because I haven't solved it for x yet. Let me multiply both sides by 2. X equals square root of 3 times the square root of 1 minus x squared. Let me divide both sides by square root of 3. X over square root of 3 equals the square root of 1 minus x squared. Let me square both sides. X squared over 3 equals 1 minus x squared. Let me move everything to one side. X squared over 3 plus the x squared minus the 1 equals to 0. That's a 1/3 x squared plus 3/3. That gives me a 4/3 x squared minus 1 equals to 0. 4/3 x squared equals to 1. 4x squared equals to 3. X squared equals to 3/4. X is the plus or minus the square root of 3 over 2. I'm sticking with that for right now. The only thing I would ask myself is if I'm going to use both answers, what quadrant was I most likely in? And let me see if I have any evidence. Well, X was positive, so I had to be in quadrant 1. So that was just an X. Did he say anything in here? I'm going to take just the positive answer. I'm sure there's a fancier way to say just the positive square root of 3 over 2. Mainly because I'm looking up here at my original equation. I had that whole thing equal to positive angle square root of, or pi over 6. So I was in quadrant 1. So square root of 3 over 2. Let's check the rest. He does a lot of gobbledygook. He lets u equal to the arc cosine of x. I didn't. I just kept it in there. Oh, he did. He did the. He did the double, or not double, the angle a plus b, and did the a and b.
You will feed him?
We knew we were between 0 and pi over 3. Okay. I'm going to call it. And there's there's that same work I did. Come up with the same equation. Solved it. Square root of 3 over 2. And works very good. And that's the whole lesson. So there's already a homework assignment already on My Math Lab. Enjoy and work work on that practice test in Naiku, and I will probably be making a lesson of Chapter 8, Lesson 1 before Thursday, but your test is still Thursday. Okay? Let me back up to the beginning.